All right, so now we've got our array list over here, and I've made sort of a visual version of this, so this is clearly just how we would visualize it. This is not really how it's working in the computer, but this is how we're going to visualize it. So I would call something like names.addNeighbors. Once I'd declared it like this, I would just have a big empty block in memory, and it would be called names, but there's not anything in there. So I call names.addNeighbors, and then all of a sudden at position 0, we're still starting at 0 with our positions, there is neighbors, which is great. Now there's a second version of the add method. Instead of just calling add with the type of thing that I'm storing, I could also call add with 2 arguments, with the position and the thing. Now if I do this, this is what happens. Whatever's already in the list gets bumped, and then the thing that I added gets inserted at that spot. So now instead of neighbors at 0, neighbors gets bumped down to 1, and Woolly's at 0. So we're going to see that one more time. Just add by itself gets added to the end of the list. A new position is added at the very end. Size grows by 1. The newest thing is at the last position. If I call it with a position, if I say add 1, and here's the thing I'm adding, then I'm going to go to that position, I'm going to insert my new thing, and everything after that, so these 2 things, whoops, are now bumped down 1 position each. Okay, that's how add works. Just add, adds at the end. Add with a position in a thing gets added at that position, and everything after that position gets moved down 1 automatically. All right, set. Set just overrides. Originally, Telez was at 3, but we're setting 3 to Ross, so 3 becomes Ross. The thing that was there is gone. And then we've got remove. Remove takes a position. So we look at that position. We delete what was there, and everything gets moved up. It doesn't just delete that thing and leave a blank spot. It deletes that thing and moves everything else up. It doesn't leave a blank spot. It just moves everything up. Okay. So the last 2, we have get and size. Size tells you how many things am I currently holding. Get, you have to give it a position. Size doesn't take any arguments. Size has no parameters. Size just tells you how many things are there. It does have to have parentheses. It's not like length. It has to have parentheses. Get, you have to tell it what position, and it tells you what's there. So if we wanted to print out all the things in the list, we could say start at 0, I is less than names.size, go all the way to the end, I++, system.out.println, names.getI. And that would start at 0, and it would get Woolly, and then it would get neighbors, and then it would get Ross. Easy peasy. Now, we could still, with ArrayList, we can still use for each. Okay? But we could no longer use get and size, because size would no longer be relevant, and get, we no longer have a position to reference. We no longer have a number. So get and size would no longer be used here. Hang on. All right. Sorry, I thought my dog was crying outside my door. Okay. So So that's size and get. You can still use for each. All right. Non-primitive data types. We're coming back to this. So we can't use int or double. We cannot make an array list for ints. We cannot make an array list for doubles, but we can use integer with a capital I and double with a capital D. Okay? So some of you may have done this on accident and it didn't backfire on you because you can declare and initialize these variables normally. This works. This works. And the way that you would do this is you can just put integer in here, and then you can just add 2, or you can add x if you've got an x up here. And what this does is it wraps the number, the primitive data type, in this non-primitive class. So it allows ArrayLists to pretend like it's a more sophisticated thing. And then you should be able to you know, mynums.get whatever number and do whatever math you need to do with it. And if it ever acts, like if you're doing this and it acts strangely, then integer has a method in the class called intValue that you can use to unwrap the number and use it like a normal primitive data type. And double has double value to unwrap the decimal value and use it like a regular number. So to declare and initialize, you just do it normally. To add it to the list, you can do it normally. And then if you're trying to do math, you just remember these two methods, depending on whether you're dealing with whole numbers or decimal numbers, to try to unwrap the value if you're not being able to use it the way you wanted to. Okay, so those are all of your notes. So last video, we're going to go over our practice problems, and then you will be free to go try your Replit assignment for the week. Okay.